Okay, for your holiday enjoyment, I want you to watch this video, figure out some things about objective test scores, what they're good for, what they're not good for, and ultimately be able to look at some students' test output and make some decisions and be able to talk to a parent about it because, part of your job in most cases, even if you're a ComDis major, will be interpreting test output and communicating what those test results mean to other people. For teachers, if you are in parent-teacher conferences and you're going over the state test scores, you should probably be able to answer the questions and know what you're talking about. And one example that has a lot of different kinds of stuff on it that I want to talk about is the Terra Nova. This is an older version of it, but it still gets at the ideas that I want to get at. And if you look at the top here in red, I have norm reference scores highlighted, and we're going to be talking about different types of that. On the bottom, I have criterion referenced scores, and we're going to be talking about those separately. Going through this, the A, B, C, D, E, and all that stuff, ignore that. It doesn't really mean anything. It just is part of the scoring guide that you would be looking at if you were trying to interpret this stuff. Now, before we look at the norm referenced test results, there's a couple things to think about. Remember that we are always having a reference group to compare an individual to. So in other words, if I'm looking at 5th grade norm referenced test scores, I have a population of 5th graders that I am going to be comparing this particular student to in order to make judgments about whether they're above average, below average, or anything like that. Okay? Now, the test norms then should match the test taker regarding their personal characteristics. So if I'm looking at Wisconsin norms, right, I should be looking at Wisconsin students. If I'm looking at a 5th grader, I should be looking at the 5th grade scores for their population. I shouldn't be trying to apply 8th grade scores and norms to a 5th grader. Likewise, I wouldn't want to use a different state, which might have different state standards, to measure academic achievement. When I think about test norms as well, and I'm making like a population to compare an individual to, if I want to create norm referenced scores for a 5th grader, I want to do it, for all Wisconsin students, I need to make sure that when I use my test data, I am getting information on a representative sample of all Wisconsin students. Because traditionally the way that this is done is that I don't give the test to everybody in the state and see where you fall, although that's possible these days. Typically you give it to a sample and you test your items on the sample and you look to make sure there's no bias and that things are valid and all this other stuff. But that sample is supposed to be like a miniature version of the state. So because most people are in southeastern Wisconsin, when we look at the population of the entire state, most of my sample will come from southeastern Wisconsin, a proportional amount. So if 70% of the people live in southeastern Wisconsin, 70% of my sample should come from southeastern Wisconsin. Likewise, if my ethnic demographics are, 50% Caucasian, 30% African American, 15% Hispanic, 4% Asian American, and so on, my sample should also represent those same norms. I should also have norms that are up to date, right? Because I don't want to be comparing my student to, student scores that were taken 50 years ago. Times change, standards change, and all that sort of stuff. Curriculum changes. Test norms should be comparable across tests. So if I give this test in May, I give it in October, I give it in the summer, maybe I change or I have different versions of the same test, I should be able to use those norms across all those different versions of the tests. Finally, my test norm should provide information so that you can make judgments about 1 through 4. All tests come with a manual. If you poke around the Department of Public Instruction website, you can find all sorts of stuff, information about how the test was put together, how it was developed, and so on, in terms of the state tests that they're using. Right now, we're going to be looking at a lot of the WKCE today, but when you guys come to class next week, we'll be looking at a little bit of the Smarter Balance stuff, which is what it is switching towards, and it's supposed to be a better way. Still a standardized test, still has all these norm-referenced ideas associated with it, just supposed to be a little bit better. Now, if we go back to this, what I'm going to do here is I'm going to take this highlighted section in red, and I just made a version that's a little cleaner, a little easier to read, and so on. And if you look right here, all these scores, I have 5 different things right here. Scale score, grade equivalent score, national stanine, national percentile, and national percentile range. Then I have these diamonds, I have these numbers here, I have this little scale down here, and I have content areas, blah, blah, blah. A whole bunch of stuff. All of these things on this page are norm-referenced scores, okay? Meaning that this score is not just based on how the person did, but it's based on how other people in their reference group performed, okay? And the first one we're going to talk about is a scaled score. And a scaled score is just a raw score that has been rescaled to have a particular mean and a particular standard deviation. Now, a raw score is just really the raw number of questions that you got correct. And so if there were 40 questions on this particular part of the test, say the reading test, well then, I'm going to take, if you got 26 right, I'm going to take that, I'm going to do some stuff with it, and depending on what the average score was, I'm going to reconfigure your score into a new range. And when we think about this, there are a couple basics that you need to know. And scaled scores are really just another version of standard scores that have been manipulated in the way that I'm talking about. A couple things that you may have gotten in different classes that you should have some understanding of what they are. Mean, well, you've heard about that since you were a child, I'm sure. Just the average. People call it the mean instead of the average, just like we have multiple names for many things. A deviation score, is then how people are different from the average. And a deviation score is positive if you are above the mean. It's negative if you are below the mean, okay? Now the standard deviation score, then, or the standard deviation, is really a way to represent what is the typical difference between any one person's score and the average score. And one thing about this is that they're always positive. And the idea is that if we have a whole distribution of scores, and say I give a 10-point quiz, and the average score is 5. Some people have 5, 6s, 7s, some people have 3s, 2s, 1s, and so on. The question is, if I look at all the deviation scores, and I look at just how many points away, so a 6 is 1 point away, a 4 is 1 point away, a 3 is 2 points away, and so on. The standard deviation is kind of like the average distance that scores are from the mean. And it's just an indication of how much people are different. In other words, if I had an average of 5 and everyone scored a 4, 5, or 6, I would have a very small standard deviation because the most anybody is 1 point away. Most people are 1 or 0 points away. Everyone's 1 or 0 points away if my average is 5 and my scores range from 4 to 6. On the other hand, if I had an average of 5 and my scores range from 0 to 10, and you either got a 0 or you got a 10. Let's say there was one question on the test, or it measured one skill 10 times, and you either had it or you didn't. Well, that would indicate, or that would result in a very large standard deviation, and my standard deviation would be about 5, because if everybody's a 0, which are 5 points below the mean, or 5 points away from the mean, and everyone else is a 10, which is also 5 points away from the mean, well then my typical distance, the average person, is 5 points away from the mean, right? Or I should say the average distance of a person's score from the mean is 5 points. And again, this isn't exactly how it works, but we're not going to go into that. And so when you have really small standard deviations, people are responding in a very consistent way. When you have a large standard deviation, people are kind of all over the place. And sometimes you want that, sometimes you don't. Now, what they do with these things is that you take the mean of the population, the average score, and you take the standard deviation, and you use that to convert anybody's individual score, which we're going to call X, into a z-score, which we're going to call a standard score. And what the z-score represents is really just how many standard deviations any one person's score is above or below the mean. If they are one standard deviation above the mean, they'll have a z-score of +1. If they're 2 standard deviations below the mean, they'll have a z-score of -2. So if you're above the mean, your z-score is positive. If you're below the mean, your z-score is negative. The average z-score is 0. And if you think about that, right, if this population mean represents the average z-score, and somebody gets that same score, so if the average is 5 and somebody scores a 5, 5 minus 5 is 0, their z-score is going to be 0. Now, from that then, based on whatever scale we're starting with, and say we start with a 40-question test, and I find out that the average number people get correct is 22, I can use that to calculate a z-score using this formula, but I then can also rescale it using this formula, which is just that original formula algebraically maneuvered so that I'm isolating the x on one side and putting the z in with everything else. So basically I'm going to multiply their z-score by a new standard deviation and a new mean. And so what I can do with that is say I have, my z-scores here, and this is my distribution of scores, right? And test A has a mean of 56 and a standard deviation of 4. These -1, 2, 3, 4 are my standard deviations. So when I have the difference between the average 56 and one standard deviation below the mean being 52, that means my standard deviation is 4 for test A. Have a mean of 56, a standard deviation of 4. On test B, I have a mean of 72, and I have a standard deviation of 6, because 72 minus 66 is 6. That's one standard deviation, so that's 6 points. And what I can do in this case is, regardless of what the average is, I can always convert scores on test A to what they would be on test B. And likewise, I can take the scores on test B and convert them to what they would be on test A. I need to make sure that the populations are consistent, and I also need to make sure that the content of the test is also consistent. And what we do with the WKCE is that they look at the raw scores, and they just they turn them into z-scores, and they rescale them to fit these cut scores, these ranges, right? So I want my minimum score to be 270 and my high score to be 640. And what they typically do is they divide, let me go back. They divide the whole range of scores into a certain number of standard deviations. And then they apply this formula to make sure that all their scores fall within these ranges. Okay, and you're typically what you're looking at is your 50% right here is the cut score, so roughly 429 or 430, 429.5, depends on what they're doing or how they conceptualize it, is your average. And then my standard deviation going from 430 down to 270, that's 160 points. And if I'm going to have this represent 2 standard deviations below and 2 standard deviations above, then my standard deviation would be about 80 points. But that's not necessarily exactly how it goes, but that's the idea behind it. And if you did the math with that, you'd find out that things don't really work, because usually what they want is you want more than 50% of your people to be proficient. So the 50th percentile actually is in the proficient range. And then you have, excuse me, a non-normal or a non-symmetrical distribution of people in these particular ranges. But that's more of a political discussion, whether it's morally justified and where you set the cut points and all that stuff. That's it's a very interesting process. For instance, last year in Florida, they had a new test, and every time you switch tests, all the test scores go down in terms of if you make sure your proficiency scores kind of represent the same number of items, right? Because the new test is usually covering slightly new content, maybe a different format, and students will always do worse on it if it is even the same level of difficulty. So a little bit is expected. But when they gave this new reading comprehension test in Florida last year, I believe 70% of the state was not proficient, according to the test, right? So they had set up these categories, and once they gave it, 70% of the whole state was basic or minimal. And so what's the solution to that? Do people say, oh no, well the test says that we're not proficient? No. Well, they say, well, we must have miscalculated on what proficient scores actually are, so let's just move that bar down here a little bit. And so we have about 2/3 of our students at least, or I can't remember, it was 2/3 or 80% being proficient. And so again, it's all made up stuff, but once you make it up and you set your criteria, you can use this to guide policy, to guide resources, and so on. And if you look at the progression, for reading scores, in grade 3, the low score is 270. In grade 4, it's 280. In grade 5, it's 290. In grade 6, it's 300. And so this doesn't mean that people are actually, getting a different number of questions right on the test, because this test is all on 3rd grade content. This is all on grade 4 content. This is all on grade 5 content, and this is all on grade 6 content. So if your ability stays the same, you should be getting the same number correct every single year. However, they want it to look like there's a progression, so it makes some kind of sense where we're trying to make this into kind of a longitudinal scale that we can use to look at progress over years. But in fact, that's not really what's going on in terms of the actual scores themselves. Math, on the other hand, doesn't go up 10 each year. It changes, and it's not always equal. From 3rd to 4th, it's 20 points, and then from 4th to 5th, it's 30 points, and from 5th to 6th, it's 40 points. Why? Beats the heck out of me. I wasn't involved in those meetings. Why you wouldn't want the low and the high to always be changing in the same number of increments, I'm not sure, unless you are saying to yourself that there is significantly more growth in these particular grades than there is elsewhere. And according to math, it looks like the amount of growth that occurs every year is growing, whereas in reading it's supposedly staying the same. And I don't know if that's true, but apparently that's what some people thought. So we're going to do something with this when you guys get back. I'll talk about it on Monday, about how you can use this to kind of figure out what your class is like, what their needs might be, and so on, and then move into map testing from there. So the second thing that I want to talk